In this video, I'm going to be explaining all the registers in the SAP2 and building the A register. The SAP2 architecture has 4 general purpose registers: the A register, temp register, the B register and C register. The A register is used for all arithmetic and logical operations. The result of an operation is going to be stored back into the A register. The temp register is also required for all arithmetic and logical operations. It's basically a temporary value. For example, loading the A register with the value 0xFA and adding 0x01 to it would mean that 0x01 is stored in the temp register. The B and C registers are other general purpose registers that are just used to hold values. To make the A register, we're going to be using two 74173s and one 74245. The 74173 is a 4-bit register, but since our computer is 8-bit, we need 2 of these. The 74245 is an octal tri-state buffer. You're going to place the 74245 on the breadboard and the 74173s on the breadboards too. On the 74173s, power is pin 16. So I'm going to connect pin 16 on both of them to 5 volts. And ground is pin 8. On the 74245, power is pin 20 and ground is pin 10. Like this. On pins 1 and 2 of the 74173, there are output enable pins and those are active low, meaning you have to connect both of them to ground to enable the output. Pin 7 is the clock pin, so we have to connect those together like this. Pin 15 is the clear pin, so you have to connect those together too. Pins 9 and 10 are the load pins, so we have to connect both of them together like this. Those are active low. Pin 1 on the 74245 is the direction pin. If it's set to 5 volts, data will flow from the bottom 8 pins to the top 8 pins. If it's set to ground, data will flow from the top 8 pins to the bottom 8 pins. We're going to set that to 5 volts since the outputs of the registers are on this side, and so this side will be connected to the bus. Pin 19 is an active high and we're going to be connecting that later. We're going to connect the outputs of the 74173, which are pins 3 to pin 6. We're going to connect that to the inputs of the 74245, which is pin 2 to pin 9. And we're also going to be connecting LEDs to the output so we can see what's happening. We're also going to connect the LEDs. Next we're going to connect the outputs of the 74245, which is pins 11 to pin 18. We're going to connect that to the inputs of the 74173, which is pin 11 to pin 14. This is the A register, but the SAP2 has 4 general purpose registers, so you need to make 3 more of these, which is what I did here. This is the temp register, B register, C register, and these are all the signals. And there are also 2 more 8-bit registers in the SAP2, the IR, which is the instruction register, and the MDR, which is the memory data register. The MDR is the data that's either from RAM or it's going to be written to RAM. The IR is where each instruction will be fetched to. For those, what you need to do is you need to take your breadboard, let's say it's like this with ground facing away from you. You're going to flip it and do the exact same thing. Since this is going to be placed on the other side of the bus, so let's say it's like this. So the 74245 is going to be facing towards the bus and the bus is going to be in the middle here. And for the instruction register, since it's only going to be reading from the bus, you actually don't need a 74245 on this. You just need to connect the inputs directly to the bus. So that's what I've done here. In the next video, I'm going to be explaining and modifying the C register to be able to write onto the upper half of the bus. Okay, bye.